Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1. Today's chapter is matrices, and in this chapter we have today's lecture is system of homogeneous linear equation. So first we will understand what is system of homogeneous linear equation. As we have seen in previous lecture, non-homogeneous system, this is homogeneous system. Okay, so you have to just bifurcate, you have to just distinguish what are the difference in between homogeneous and non-homogeneous. Okay, other than that, there is no any difference in method, Gauss elimination and Gauss-Jordan elimination method. So system of homogeneous linear equation. So system of M homogeneous linear equation in n unknowns, that means variables, is represented by this. That means same system but with is equal to 0, 0, 0. Each and every equation is equal to 0. This system is known as homogeneous linear system. Okay, and in matrix form AX is equal to 0, not B. B, that means any constant number, and 0, that means 0, 0 matrix. Okay, so we have this A is coefficient matrix, X is variable matrix, and this is our 0 matrix. Now we have the solution of system of linear equation, that means homogeneous linear equation, and for that there are only two possibilities. As we have seen in a non-homogeneous, there are three possibilities: unique, many, and no solution. If unique and many solution, then we can say that system is consistent, and if no solution, then we can say system is inconsistent. Here we have only two possibilities: either system consistent, okay, or no, only consistent. Okay, so homogeneous system is always consistent, because of that equal to 0. Okay, so homogeneous system never become inconsistent. But in the part of consistent, homogeneous system is always consistent. In that we have two types of solution: unique and many. Okay, unique and many. Unique, that means we will get the answer exactly one solution, that means unique, and we will get the answer x1, x2, x3, all the variable is equal to 0 compulsory. And this is known as trivial solution. This is known as trivial solution. If solution is 0, 0, 0, 0, 0, then we can say that it is trivial solution. And if we have to suppose some parameters, like we have seen that one method is remaining our, then system is infinite solution, and it is called a non-trivial solution. It is called non-trivial solution. So we have here only two possibilities: trivial and non-trivial. Trivial, that means all the variables will 0, 0, 0, but the solution is 0. And non-trivial, that means many solution. Infinite solution, that means infinite many solution. Okay. Now one remark is that the system of equation has a non-trivial solution if non-trivial solution, that means many solution, if determinant of A is equal to 0. Determinant of A is equal to 0. That means determinant of A, that means coefficient matrix. In this, AX is equal to 0. Okay. So if determinant of A is equal to 0, then we can say that system has a non-trivial solution. By using this remark, we have very interesting example that I have given in DIY. You have to think about that. Okay, I am giving hint from here that there is some question like find the value of some unknown lambda or mu or anything else. If system possesses non-trivial solution, system possesses non-trivial solution, that means system has a non-trivial solution. That you have to just find A and find the determinant of A, and by solving determinant of A is equal to 0, that equation, you will get the value of lambda. Simple examples. Okay. Now to understand better solution, that when the system of linear equation has one or more solution, system is said to be consistent, and this is our A0, we can say that 0. Augmented matrix is called augmented matrix, as we have seen in previous lecture also. To solve the system of this homogeneous linear equation, elementary row transformation is used to reduce augmented matrix, this given matrix, into either row echelon form or into reduced row echelon form. Based on this row echelon form and reduced row echelon form, we have two methods. In reduced row echelon form, Gauss-Jordan, and in row echelon form, Gauss elimination method. Okay, so in method there are no any change, only change is this equal to 0, and change is system has only two possibilities, trivial and not trivial. That means 0 0 0 or many solution, not inconsistent. Okay, this system never become inconsistent. Okay, to understand better, we have very first example. We are taking only two example. Then after I am giving you practice example. So pay more attention. We have to solve following system by Gauss-Jordan elimination method. Gauss-Jordan, that means by reducing into reduced row echelon form. This is the system. Equation 1, 2, 3. Okay. So first we will write down in matrix form Ax is equal to 0. You can write B also, but B is equal to 0. Okay. So this is our matrix form. Now augmented matrix. So A0 is equal to this. Now we have to reduce this into a reduced row echelon form. So start from this. We will make one here. To make one here, we can change the row, interchange the row 1 and 2. Okay. So let's start the operations. So first we interchange on this. So by interchanging first and second row, we write down R12. So second row becomes first and first row becomes second. After getting this one, make this two number 0. So operation is R2 plus 2R1, R3 minus 3R1. By applying this for second row, applying this to third row, we have these two. This is 1. Now making this 5 1, we will divide 1 by 5. So multiply by 1 by 5 R2. So 1 by 5 R2. So we have 1 1. Now we have this one. We have this one. Now by using a pair row operation, R3 plus 6 R2. We use second row. R3 plus 6 R2 operation also apply here. So we have this matrix 1 1 and this is 2. So make this minus 2 as 1. So minus 1 by 2 R3. This one. So we have this matrix 1 1 1 and 0. Now this is Gauss-Jordan. So we have to reduce into reduced row echelon form. So after getting this row echelon form, start from the right side. So making this 2 0. Operation will be R1 minus 3R3, R2 minus R3. R1 minus 3R3, R2 minus R3. So we have this, and this is leading one, this becomes 0. Now to make this term 0, okay, so R1 minus 2R2, R1 minus 2R2. So we have this matrix. After getting this is our reduced row echelon form. Write down the corresponding system. So we have x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. And we have the solution 0, 0, 0. So we can say that this is the trivial solution and system is consistent, simple. System has a trivial solution. Okay. So now one more example. We solve the following system by Gauss-Jordan elimination method, and this is the system. Equation number 1, 2, and 3. And we have 4 variables. You can see x1, x2, x3, x4. Okay. In some equation, x2 is 0. In some equation, x3 is 0. Some equation, x1 is 0. Now write down an x4. This is the fourth equation. Now write down in matrix form Ax is equal to 0. We know that this is coefficient matrix, variable matrix, 0 matrix. Now write down the augmented matrix A0. Now converting this into reduced row echelon form, make 1 here. So 1 we have this 4 in 4th row. So we can change 4th and 1st row. So R14 we will apply. So we have this R14 and by applying R14 we have this matrix. Fourth row becomes 1 and first row becomes fourth. Okay, now we have operation. Now pause the video, complete the example, then start the video. Okay, so we have operation R2 plus R1 and R4 plus R1. Yes, there you are. Then we'll apply this operation. So first row as it is, third row as it is, second and fourth row will be changed. Now we will make 1 here. So by multiplying -1 to R2, so -1 R2 minus, the minus become plus, plus minus minus. This is 0. So we have this. So this is 1, this is 1. Now make this 2 0. R3 plus R2, because as I told we will use second row. R3 plus R2, R4 plus 2R2. We have these two operation, and applying this operation we have this matrix. Okay, if we apply that two operation, last two row becomes 0. So this 0 and this is 0. So no need to use 0 is equal to 0 is possible. Huh? Okay, so we have corresponding system of equation. Before that we have to convert this matrix into reduced echelon form now, because this is Gauss Jordan. So we have to make this 0 minus 2. So R1 plus 2 R2, we will use second row, no column operation. Okay, now by applying this operation we have this matrix. So this is 1, this is 1, and these two column contain leading 1, and in that column other than leading 1 all the elements are 0. So this is our reduced row echelon form, and by corresponding system we have two equations. This first equation, x1 x2 is 0 minus x3 minus 2x4 is equal to 0. x1 is 0, so x2 minus 2x3 minus x3 and minus 3x4 is equal to 0. We have two equations. So now we will find the free variable. Why we have to find free variable? Because we have 4 variable is given but 2 equation. So there is no possible solution we have, because rule is to solve 3 equation, 3 variable is needed. We want to solve 3 equation with 4 variable, that we have to suppose 1 variable. Same concept here, we have 4 variable and 2 equation. So number of variable 4 minus number of equation 2 is equal to 2. So we have to suppose 2 parameters out of these 3. Okay, we have to suppose 2 parameters. That means either you can suppose x4 or you can, from the bottom, you can suppose x4 or you can suppose x3 or you can suppose x2 or you can suppose x1. Whichever you want to suppose, you can suppose, but always try to suppose from the bottom. That means x1, x2, x3, x4. So start with the x4 and x3 and so on. So if we suppose x4 and x3, okay, x4 is equal to k1 or x4 or x3 is equal to k1. So one of these is k1 and one of these is k2. So k1, k2 we will get x2. Same way, by putting k1, k3, k4 value, we will get x1. So we have x1 and x2 in the form of these two, and by putting, as I told, we have to compulsory suppose only 2 variable. 2 variable, not more than 2, and that 2 variable suppose is called parameters. Not a more than, not less than. Okay. So but after supposing 2, we have x3 is equal to k1, x4 is equal to k2. By putting this, we have x1 and x2 in the form of k1, k2, and this k1 and k2 belongs to capital R. That means any real number. If we change the value of k1, k2, according to that k1, k2, we have the value of x1, x2, x3 will be changed. If I take 0 and 0, 0, answer will be changed. If you take 1, 1, answer will change. If you take 0, 1, then change. 0 minus 1, change. 0 minus 2, 0, 1 by 2, 1 by 2, root 3 by 2, any number, any real number you can take. As many. That means system has infinite many solution, because k1, k2 are arbitrary constant. That means any real number, that means arbitrary constant. So system has infinite many solution, and therefore system has a non-trivial solution. Okay, so this is the example based on infinite many solution. So in previous lecture, if you did the practice example and if you get this kind of problem that you have number of obtained equation is lesser than number of variables. You have three variables and you obtain two equations only. So 3 minus 2, that means 1. That means you have to suppose one variable. If you get only one variable, one equation after reducing the row echelon form or reduced row echelon form and getting your corresponding system, one equation, three variable. So free variable becomes 3 minus 1. That means 2. You have to suppose two variable compulsory, and that two variable are known as parameters. Okay, so these are the methods how we can solve homogeneous and non-homogeneous system. Both have same solution method, but some concepts are different that you have to just remember in your mind. So we have this idea. Practice example. So you can solve by yourself, and if you get any queries, then you can contact me. I will give you hint, or I will help you. And this is the example for what value of lambda the system possesses a non-trivial solution, as I told. So first write down this system matrix form. After getting matrix form, you have matrix A, and in that matrix A you have unknown lambda, and as I told, system has a non-trivial solution, and determinant of A is equal to 0. So determinant of A is equal to 0. After solving this determinant, you have one equation in the form of lambda cube or something, and by solving this equation you will have lambda. Okay, and after getting this lambda, solve the system by putting one by one real value of lambda, complex value of lambda 9. Okay, so this is the example, and these are the more example. Total 7 example we have. Solve one by one. I have just put one short question also, so you can understand if in some competitive examination or in examination if MCQs are there, how you can solve this MCQ. Okay, so keep watching, and thank you for watching this video. We will see you soon with upcoming next lecture. So use pen and paper always, as I said. Then and only then you can understand better this lecture. Keep rewinding this lecture. If you find any query at any point, you can contact me. Okay, so thank you for watching this video.